Hi, this is Amin, and in this video, I'm gonna give you an introduction to OpenStack. So, when we're talking about OpenStack, the first things that jump into our minds is virtualization and cloud. So, before talking about OpenStack, let's have a brief review on the virtualization and cloud, and then we're gonna go for OpenStack. So first thing first, imagine this is the basic architecture. What do we have? Maybe it is our computer. So we have memory, CPU, NIC, disk, all of them. All together is our computer. So we have an operating system on that. Maybe it's 64-bit or 32 bits. And at the topest level, we have our application. Maybe, I don't know, we are using the computer for game, maybe for doing some projects, I don't know, MATLAB, or for just watching a movie, something like that. So this is the basic architecture. But what if via software we can divide or a computer to different computers, or we can virtually have different operating systems on a computer. So whatever we have here are virtual. This is the main computer. We have our basic structure, but on that, in a virtual way, we can have different CPUs or different, I don't know, network interface card or maybe memories, and make these are maybe CentOS, Ubuntu, something like that. So via VMware, Oracle, VirtualBox, I don't know, KVM, then we can have different operating systems. So this will be the concept of virtualization. And the simplest example that I can tell you uh, is our computer drives. For example, if you take a look at that somehow deeper, you know, we just have one hard disk in our computer, but we have different partitions. You know, we have I don't know, drive C, drive D, drive F. How? It is a way of virtualization. We have one hard drive, however, different partitions. So it's a kind of virtualization. And if you would like to continue this idea when we are talking about virtualization. So we can have cloud. What is cloud? Cloud is nothing but just some services. For example, pictures, emails, video, calendar, I don't know, chat, whatever we can do, we can use them based on internet and maybe via our laptop, desktop, or I don't know, tablet, mobile, but they are not here. Maybe you can chat or make a video call with a friend who lives overseas. How? Via cloud, via some services that are not here, I mean, in front of you, some infrastructures on a cloud, and you can use them. So basically, this is the concept of cloud. Let's continue. If you would like to talk about cloud more, we can categorize that in these three things. The first thing, which is IaaS, infrastructure as a service, and exactly the OpenStack is here, is something like having some servers and running everything on the servers. So the servers, the computers, the networking, all of them are infrastructure. The second thing is a PaaS or PaaS is a platform as a service. So what is a platform as a service? It could be our operating system, for example, Ubuntu, Linux, I don't know, Windows, something like that, that we are using that platform to develop our project. And finally, SAS, software as a service, and it could be Gmail, maybe Google Drive. So we can say cloud computing is a type of internet-based computing that provides shared computer, which is our infrastructure, processing resources, and again, it is our infrastructure, and data to computers on other devices on demand. So this is the concept of cloud computing, and we can categorize that in these three things. Also, if you want to look at that deeper, we can say, okay, clouds. What is the cloud service stack? What is the cloud service stack? These are the layers of that, and at the first layers we have these three: servers, storage, networking, which are the hardware. And then we have virtualization, I mentioned, and operating system, a middleware. What is middleware? A computer software that provides services beyond those that are available from an OS. Something like RapidMQ, for example. These are that softwares. And also we have runtime. We use that for it is for data recovery software, applications, and data. The last thing that we're gonna store that, and we're gonna see that part. But this is the service stack, all of them, of what of the cloud. And we can take a look at that based on what I've mentioned, like this. In IaaS, which I told you, it's our Openstack, networking, storage, server virtualization will be managed by the vendor, and the rest of that is your responsibility to manage the operating system, middleware, runtime application. But in PaaS, like Ubuntu, so all of them, I mean, networking, storage, and till uh, runtime, all of them on Ubuntu. And what you're doing, just you run something, run an application on Ubuntu, and you have your data on that. So you're gonna manage that part. And finally, on Google Drive, just you have your data on that. So this is another way of taking a look at that concept and cloud computing and virtualization. Or what's that? Imagine a tenant consumer, someone who's using a service, sends a request towards the IP department, and it's gonna send that towards instances. What's that? So imagine you have a cloud service, and this is your maybe VMware. You have a cloud service, and you're gonna do what? You're gonna run some instances on that. You have your maybe computer, or maybe your, I don't know, something you rented from Amazon AWS, and you're having a computer here, you have a router on that, or you have something more here. So these are your instances, and you are using VMware to achieve that service. But another way to view that is that maybe you're doing some sort of huge computing. So you're gonna have different servers and connect them to each other. Just run one instance here to have big data analysis. But here in cloud, we can say there's a user, it makes a request towards the cloud, maybe it's a video chat. And what do you need? You need a compute resources. So that cloud, or for example, WhatsApp, it will give you compute resources, and also at the end, you have a pool of a storage to store your data. And what do we have here? We have APIs here. What is API? API, we'll hear that name more and more. API is something that enables you to communicate between services. And what is southbound? So imagine there are layers, different layers like that picture. And the way of communicating like this from the user to the end of the path, this is southbound, and whatever goes up, it is northbound. So this is the concept of south and northbound, and API and cloud. So let's continue. What are types of cloud? We have three types of cloud. The first one is the public one, which you are here. You're gonna use a public cloud. You have something on Amazon AWS, and you're gonna connect to that. So there's a firewall here which is provided by that public network provider. But here in the private, the situation is somehow reverse. The instances are here, and it's a private one. I'm sorry, it's a private one. So what do you have? You're gonna connect to your instances, and you set firewall here to protect your service. And finally, hybrid, you're here. Maybe you have big data analysis and your processor on your cloud is not good. So what do? You'll use a public one to use the data analysis, and via a VPN tunnel, you're gonna send all of them here. Or maybe you do not have an area for storage. So what you're gonna do, you're gonna do all of the calculations, all of the computing and data analysis here, and finally you're gonna send them here for storing. Or maybe everything is good here, but you just need a backup, and you're gonna send them here to store, and this will be your backup. So let's go for the OpenStack. OpenStack is a collection of open source technologies, and it's open source. The best part of the OpenStack is it is open source, and it's delivering a massively scalable cloud operating system. At first, it is delivered by Rackspace for NASA, but now there are many companies like Cisco, IBM, HP, Dell, VMware. All of them are working on that to improve that and develop, and they're gonna work on coding and something like that. So, what else? The last thing about before jumping into OpenStack, just reviewing the pros and cons of a public cloud. What do we have? The most famous one is AWS, Amazon. And it is clear, uh, it is needless to say that whatever has its own pros and cons. So, what is the pros? It is well documented in APIs. So, the APIs are perfect, extremely good, documented. It's fast processing, so it can process everything very fast. By just ping to Amazon and having your cloud, you can have the best computer on your cloud and do all of the processing. It's extremely fast, good, full autonomy for developers. Tools and ecosystems are perfect, and it's very adaptive. We have, I don't know, Git, whatever you can imagine, you can have them here. But for the cons, maybe proprietary in the APIs, or for example, as long as you are just computing, you're storing, everything is good. But whenever you want to have your data, maybe you encounter data sovereignty issues, or in the networking, the environment is somehow different. And finally, maybe you have some sort of data that you do not like to share on a public place. These are, I mean, confidentiality now is a matter. So for that case, maybe it's not good to go for the Amazon. So let's go for the deployment models of OpenStack. The first one is open premises distribution. What's that? You have your own OpenStack, so you can download and install whatever you want on your OpenStack, and everything is on your hand. Second one is using public cloud, OpenStack based public cloud. It's like exactly like Amazon. So there's a vendor that provides you public cloud for the computing and for whatever you're gonna do. The third one is the hosted OpenStack private cloud. What does that mean? It means there is a that vendor will give you a private, so that issues like data sovereignty, or I mean sensitive data, are not matter, and you're just gonna pay for the support. So there is a vendor that the vendor host an OpenStack based private cloud. So you're gonna just use another vendor OpenStack in a private way, or OpenStack as service. What's that? You're just gonna, for example, call, I don't know, vendor something, I don't know, XYZ. Let's say a number, a name just, and just call and say, okay, I would like to have that service, and you'll be charged just for that service, not more. So there is a vendor hosts OpenStack management software, and you're gonna just get a software from that vendor. And finally, appliance-based OpenStack. So software do not require an OS to run. It was Nebula was a vendor, at first, that sold appliances that could be plugged into a network which spawned an OpenStack deployment. So these are the deployments of the OpenStack. But on the whole, we can say OpenStack is a combination of some services. And what are those services? The first one is Killstone. So what's Killstone? Identity service. Who you are, what you're gonna do. This is the responsibility of this service, Killstone. And then Horizon. What is the Horizon? This is the web UI. This is the dashboard that you can see visually. And it's not like coding, but this is the dashboard that you use as an interface between you and the OpenStack to work with that. Nova, or compute service. Actually, it is the brain of the system. It's gonna just do all of the computing. Neutron, for people who like Cisco, I would say it's a router. So it does all of the networking. Heat, it does orchestration. I'm gonna explain that to you. Glance, everything is like an image. I mean, operating systems like Ubuntu, CentOS, I don't know, Fedora, whatever you're gonna run, there should be an image for that. So the images are in Glance. Ceilometer, it's for metering data collection and providing a bill. Cinder, it's a block storage. So we can see everything as a block to store. Trove, it's a database of the services. Swift for the object storing. So after that, you'll see you're gonna just, there's a Swift proxy and different objects to store. Sahara is it for big data processing framework, and Magnum at the end is a container for orchestration engine provisioning. So let's continue and explain all of them one by one. The first thing is Keystone. So as I told you, authentication and authorization, who you are, what you want to do. First, the first thing when you want to use a service, I don't know, when you want to connect to a device, you should identify yourself. How? By username and password. So it identifies if you can log in at first. So the first thing is the keystone. So you're gonna provide username and password, and it will check if it is true. Then, are you eligible to do something with that service? So this is the concept of Keystone, but it has some parts we can see here. The first one is token. What is token? Token is gonna validate and manages tokens for authentication. So this is the responsibility of token. We have catalog here. What's catalog? It's for communication to endpoints. So imagine you're here, you're gonna, I don't know, use some sort of, and you're gonna pass some layers, clouds, and then this is the parts that you're gonna use. You're gonna, I don't know, communicate with that. This is your endpoint, and this is responsibility communication from that part to the endpoint is responsibility of catalog. I mean, every time you want to use a service, it should be validated, and this is the responsibility of on the whole all of them. But we can say it's responsibility of Keystone, and we have policy. What is policy? Uh, we can say it's a rule management, something like that. For example, there's a company policy, so for authorization, something like that. And also we have the resources. I mean, stores the domains for us. Assignment, it stores roles, and we call that role assignment, and also identity, the identity of the users. So this is the keystone, the first thing. Second one is the glance. What is glance? So as I told you, we have API. What was the API? Something that I told you enables you to communicate between services. So user is here. Users want to just run something. Look, Glance project provides a service where user can upload and discover data assets. So all of the images or metadata definitions, all of them are here. It depends on you what you're gonna do. So we have a database here, and whenever you would like to run an image, you would like to do something, we should go to the glance, and on that glance, based on our database, run that image. What's next? Nova. What is Nova? So we can say Nova is the brain of the system. It's the computing zone where your instance get launched in, and all of the processings are here. Look, also in Nova, we have an API, we have a scheduler. So based on what you're gonna do, they should put in order, and after scheduling, they're gonna be in queue. It's a rapid MQ. Uh, Based on that, so all of the queries will be scheduled and then go to the queues. We have our Nova database and also computing and networking stuff. So Nova is connected to rest of the, I mean, services, and this is the concept of Nova. We can say it's like a CPU. It's not good to just say Nova is a CPU, but it is sometimes good to learn better to try find some similarities. So Nova is our brain, and then we have our neutron. What is a neutron? Neutrons like networking stuff, and the concept is somehow the same with Nova. We have our API, we have our scheduler, and it sends requests towards the queues and put them in order. And Neutron is a networking project focused on delivering network. They call it NAS, networking as a service in virtual compute environments. So this is the networking of that, and we'll see in the horizon, the next videos, that just we're gonna set IP address, subnet. We're gonna just connect the routers to each other via Neutron. Let's continue. We have Swift, and what is Swift? At first, it is good to know big companies are using that, for example, Wikipedia or Comcast, something like that. But objects, we can call that object storage service or data storage system has changed everything. Data storage system has changed everything and stores things as an object. Swift is the service that allows you to do that in the OpenStack. How you have a query or some request, it goes towards the Swift proxy. For example, it sends towards the account. We have account database. What is account database? For example, for the user accounts, user admin, maybe there's a demo. And I would say maybe we have a container. So we're gonna just store something inside the container. What is container? It's nothing but a file, but there's a big difference between file and container. We can have different files inside the file, but for a container, just we have a container, and we cannot have different containers in a container. And finally, store things as an object. So let's recap. Whenever there is a request for storage, the this part. The Swift proxy will get that and redirect that to a proper container. This is the concept of that. I'm not gonna read all of this. You can read these. Just I provided them. If you want, you can read them. And then we have Cinder. What is Cinder? Cinder is we can consider Cinder like an external memory, something like that, external hard drive. Everything is like a block, and each block has a different size. That data will store in a block. These are the this is the architecture of the Cinder. We have Cinder volume, backup, a scheduler. It has its own SQL database, and we have another thing like Swift, and Swift as I told you, it's like a memory, and Cinder also is a memory for storing. But what's the difference between Cinder and Swift? So when we try to just store something in the Swift, it's not important for us where it is stored or how it is stored. We're not gonna know that. We're not gonna investigate for that. We just have a link for the Cinder, and by clicking on the link, we can access to the thing that we stored on Swift. But what if we lose our link? So we cannot reach our data again. But here in Cinder, we can have our data always. And there's another thing which is important. Cinder is only for storage. It does not communicate with Nova directly. So imagine whenever you're gonna run something, so Cinder should use some sort of networking to communicate with Nova with other parts, and it will cause some sort of latency in the system. It it has to go through the glance if you want to launch instance on Cinder, and it's not good. You can again we can consider that as an external hard drive for storage. What we have afterwards, a horizon. Horizon is our dashboard. Whenever a user, I don't know, no matter who, end user admin wants to do something. So at the first thing is the horizon. Maybe you're just gonna run an image, or you're gonna store something in the Swift or some sort of, I don't know, computing. This is the gateway that you should see. This is the first door. So the dashboard, which is based on Django module, and we call that a Django OpenStack, is the horizon. It's our dashboard to use the system, the services. And Ceilometer, what is Ceilometer? Something is responsible for monitoring all of the actions that you did. So it's for the telemetry project. It's gonna monitor whatever you are doing, and later on, it provides bill or providing bills of how many services for how much time you have consumed. Maybe you are owner of a cloud service and you have some customers, some consumers. As we can see here, we have external system consumer, and you're gonna just charge them for the service that you're delivering to them. And this is responsibility of a Ceilometer. This is the concept of Ceilometer. And the last part, I think, it's Heat. It provides a REST API to orchestrate multiple cloud applications, implementing a standard such as AWS Cloud Formation. So what does that mean? Let's see. We can say Heat is responsible for orchestrating different services. What does this mean? Orchestrating, I would say, defining how each service would get consumed or will get triggered. I mean, for example, Killstone, it somehow checking the authentication and then go for token, and it will be trigger, I don't know, maybe Nova. So Heat is responsible for orchestrating all of them. And sorry, the last part, or the last slide, if we take a look at the whole uh, architecture diagram, we'll see as a user, we're gonna use the system. So we have horizon here. The first thing, look, we have GUI, management GUI dashboard. So we're gonna just use a service. The first thing is going towards the keystone for authentication. If it is okay, then you're gonna go to the neutron. So to connect the VM, after connecting to the VM, maybe you're gonna run, I don't know, Ubuntu. So for Ubuntu, you need an image for that. You need image repository for that. Maybe there are some data which is here in Trove in the database, and on your Ubuntu, you have some sort of data which is stored before. So you need to connection between Swift or also for Cinder. And then you're gonna run something. Maybe you're working, I don't know, in Open5 just project. So you're gonna have different Ubuntu's, different virtual machines. So lots of computing. You have one core, you have your inodb, you have your UE, you have your RAN. So this one, Nova, will do all of the computing, and Ceilometer will check the uptime of the system, and if someone is using that for the billing. And also Heat will do all of the orchestration. This is all of the concepts which were related to the uh, OpenStack. I hope I tried to shed some lights on the OpenStack. I hope it was good for you. I hope you enjoyed. If you enjoyed, just show a thumbs up, hit on the like button, and if not, thanks for watching that video. Don't forget to subscribe the channel. Bye everyone.